Okay, let's go through these population problems with the right numbers. You guys did not tell me in class I was using the wrong numbers for a couple of these, so let's get this correct. Okay, so population, here we go, first try. So the first question's wanting to know about population density, which is the number of people in the population divided by the area that that place is. So the first question had 250,000, let me fix that, 250,000 people in a area of 5,000 square miles. If you just divide those together, you get 50 people per square mile. Number two, wanted to know about the birth rate. So birth rate is the number of births divided by total population. In this problem, there were 12,000 births, and the total population is still 250,000 people. And that gives us 0.048. We times that by 100 to get the birth rate, so that'll be 4.8 is the birth rate. To get the crude birth rate, you multiply by 1,000, so that gives us a crude birth rate of 48. So depending on what the question's asking. Our question asked for the birth rate, but I'm doing crude birth rate because of what's coming up. The death rate, don't forget there's two parts. It says calculate the birth rate and the death rate. Sometimes students get all happy that they did the birth rate and forget the death rate. Number of net deaths divided by the total population. So this one was 10,000 divided by the 250,000 total population, and that gives us 0.04 times 100 gives us a birth rate of 4, or if we times it by 1,000, it gives us I did it again, a death rate. See, I was worried about you guys doing it, now I'm doing it. Death rate, or a crude death rate of 40. There. Okay, and then number 3 wants to know the growth rate. So this is the reason I did the crudes, because if you take your crude birth rate subtracted from your crude death rate and divide it by 10, that's your growth rate. And so I can do 48 minus 40 divided by 10. That simplifies to 8 over 10, which simplifies to 0.8. So that's my growth rate. And now when they want the doubling time in years is 70 divided by the growth rate. So I know my growth rate from number 3, so it's 70 divided by 0.8, and that will tell me 87.5 years. So it'll take 87.5 years for this population to double its current size. Okay, so that's section 1. All right, section 2, we have a new population. We have 2,300,000 people in an area of 800,000 square miles. And what's the population density? So we put that in our calculator. It's 2.875. So there's almost 3 people per square mile. That's pretty spread out if you think about it. Okay, then number 6, you guys in class didn't call me out on my little mistake here. So let's do it correctly. The birth rate is the number of births, which was 109,000 for this place, divided by the population. I was using 800,000, which was the area. No one said anything. So it's really 2.3 million. And that comes out to 0.047 times the 100. So 4.7 birth rate. And might as well do the crude. So it's 47 crude birth rate. And then again, the death rate, it was 111,000 divided by that 2.3 million. And that comes out to 0.048 times 100, so 4.8 for the death rate. Or for the crude death rate, multiply it by 1,000, so 48. So then number 7 wants the growth rate. Well, this one's a little weird because it's the birth rate minus the death rate over 10. So now we have negative 1 over 10, so we have a negative 0.1 growth rate, which means for question 8, there is no double of population because it's a declining population because, as vampires are eating all their victims. Okay, so number 9, we've got a situation of a doubling time. So the growth rate's 1.3. How long will it take for that population to double? That will be 53.8 years. How old will you be? Well, I will be 103, so like I said in one of my classes, I'll be dead. Okay. Okay, so number 10, the doubling time. This time we have the doubling time. Remember that's 70 over the rate. But this time we want to calculate the rate. They gave us the doubling time in years, so we need to rearrange the equation. So if I multiply this side by r and this side by r, and I divide this by doubling time and this by doubling time, I'll get my r. So my r is 70 over 56, and that gives me a 1.25 growth rate. Okay, the next one, the big chart. I'm just gonna put the first letter of the country. So United States, Mexico, Japan, the UK, I guess I'll put a K there, China, India, Nigeria, I don't know what that was, S, I can't read my notes, and Italy. Oh, we're doing populations, okay? All right. So you don't need the country's population. You don't need to look up anything to do these. You just need to remember birth minus death rate divided by 10 is going to give you your growth rate. And you have that on the chart. And then for the doubling time, all you have to do is 70 divided by your growth rate, which is in this column right here. So these births and deaths are already in the chart. And so all you have to do is subtract them and divide by 10. So the US would be 0.5. Mexico's turns out to be 1.4. Japan was negative 0.1. The UK was 0.4. Not negative, just 0.4. My writing is bad. Canada was 0.5. India was 1.6. Nigeria was also 1.6. Whatever the S country is was 0.7. Canada's 0.4, and Italy was negative 0.1. And so then all you have to do is take this number and plug it in right there to get all these doubling times. So the US was 140, Mexico was 50, Japan is never because they're negative, the UK is 175, I feel like we should check that one. 140. Italy is, lost my spot. Oh, it's India. Sorry. India is 43.7. So is Nigeria. 100. Canada is 175, and Italy's never. So notice the countries that have the smaller growth rates take much longer to double their population. And the countries that have really large growth rates, it doesn't take very long at all to double their population. That's what you should come away with from this little exercise here. Okay, number 12. So, little formula from up top. You take your initial population, you multiply it by the growth rate to the power of however many years you want to project into the future. And that'll give you your final population. So let's look at this. The question was asking us in 5 years with this population at this growth rate, what'll happen? So the growth rate they gave us was 1.012. And the way we find that is because it was 1.2, and so we have to move it over to our percent. So that's the 1 and the 0.12. Hope that makes sense. It's on the front of the worksheet, which I don't really have in front of me right this second. Okay. My dog is eating my carpet, you guys. Okay, so I'm going to take the population they gave us, 127,904, times the growth rate, 1.012 to the power of, and it asked at first, I think it was 5 years, so this is to the 5th power. So in my calculator, I'm going to type 127,904 times, and then this, in your calculator, you would go 1.012 caret 5, and it will tell you that number. And if you do all that, you should get 135,765 people at that growth rate. So this is at 5 years. And then they asked us to do the same thing at 10 years, this exact same thing. And you just put in the power of 10. 012 to the power of 10. And that should come out to 144,109 people. Peeps. No, dog. Bad dog. Oh my gosh. Okay. At 50 years, same thing. 127,904 times 1.012 to the power of 50. And then we'll get 232,225 people. I'm just being funny. And then at 100 years, same thing. 127,904 times 1.012 to the power of 100. And we'll get 421,633 people. That's quite a bit.